In this article, you're going to be reading more about the transitional whale fossils that scientists have found and what they see in the fossils and what inferences or conclusions they can make. So, the goal of this assignment is while closely reading the article, you're going to be highlighting observations and inferences. Observations are descriptions or facts about the fossil, and inferences are conclusions made about the fossil or what scientists think based on the facts. So, what I'd like to do is help you get started. I'm going to show you how to highlight on a digital version of the article. So let's go ahead and move over to Google Classroom. So the first thing you'll see in the assignment is directions for using Cami. Cami is an extension you can add to Chrome, and it allows you to modify PDFs. So you'll just click this link here, and then it'll take you to the Chrome Web Store and make sure you download Cami. Once you do that, when you open a PDF, you'll see a button. It's a blue button that asks you to open with Cami, and then it will allow you to highlight the text and save changes when you're done. So here's the article that you're going to be using, and notice I have the button open with Cami. And once I do that, and I've already zoomed in a little bit so that when we go through it, it's easier to read, okay? The main thing you're going to be doing with this article as we read closely is highlighting two things: observations about the fossils. Observations are facts that the scientists see, and then inferences. Inferences are conclusions scientists make based on the facts. So it's what they think. An inference is what they think, and an observation is what they see. It's a fact that's true. So if you'll notice here on markup, you can pick highlight text and then you can pick color. So you'll want to make sure you pick two colors. I'm going to use yellow for highlighting the observations or the facts, and then I'm going to use green for highlighting the inferences. So let's go ahead and start reading, and then I'll go back and highlight. All right, so if whales are mammals, how did they come to live like fish? Could their ancestors have been land mammals that gradually took to the ocean? When scientists first asked these questions, there were little fossil evidence to provide answers, until that is, paleontologist Philip Gingrich discovered a bone in the desert of Pakistan. Many of the great scientific discoveries happened by accident, if the scientist is open to surprises. Philip Gingrich wasn't looking for whales when he arrived in Pakistan in 1977 with a team of international scientists. Dr. Gingrich was an expert on extinct land mammals, so he was disappointed to find that the first place he had targeted to look for fossils was an ancient seashore. The rocks were filled with fossilized snails and other shellfish, not the best place to find the bones of a land mammal. Like kids in a giant sandbox, Gingrich and his team went to work anyway. After a week of scouring the exposed rocks, they found a few pieces of bone that looked promising. They could make out part of a pelvis and backbone. Gingrich recalls joking around with his team about finding a walking whale with hips and legs, but back then it was just a joke. The team assumed the fossils were bits and pieces of an ancient elephant ancestor, a land mammal that had drifted out to sea after death. Okay, now let's move on, because right now in these first three paragraphs, it's just setting up how did this happen, which scientists were involved. But so far, they're not telling us about specific fossils. All right, paragraph 4. But on a December day in 1979, the team found a specimen that was not so easy to explain. Embedded in the rock, as hard as cement, it was a curious fossil skull. Gingrich took the skull home to his lab. When the fossil was cleaned up, Gingrich could see that it was no bigger than a wolf skull and had many wolf-like features. The teeth were a mix of canines and molars, and the nostrils were set close to the snout. But attached to the skull was a set of tiny, thickened ear bones. The only animal on Earth, living or extinct, that have ear bones thickened this way are whales. So Gingrich named the creature Pakicetus. Pakicetus, whale of Pakistan. It lived 48.5 million years ago. Based on the land mammal-like features of the skull, Gingrich hypothesized that this whale probably went to the water to feed, but came on land to rest and give birth. After an unexpected discovery of Pakicetus, Gingrich began to hunt for whales in earnest. Whale fossils are large and they are relatively easy to find in the desert. Sometimes the wind lends a hand by scouring away the sands and shells, leaving entire skeletons exposed. One valley in Egypt was especially rich in whales. On a series of visits in 1983, Gingrich and his team found virtually a whale a day. The final tally came to 379 whales. He found some with hip bones, but Gingrich also hoped to find feet and legs. All right, so let's go back up. In paragraph 4 and 5, Gingrich found a fossil named Pakicetus, or which they named Pakicetus. So let's go ahead and highlight what are the facts that we know about Pakicetus. What did they observe, the scientists? So if I go back to paragraph 4, Gingrich took the skull to his lab, and when it was cleaned up, here we go. It was no bigger than a wolf's skull and had many wolf-like features. And again, originally he was looking for land mammals. So the teeth were a mix of molars and canines. And nostrils, again, nostrils are the nose holes, were set close to the snout. Snout would be like the end of the nose. So very much right now, it sounds like they're describing a wolf or a dog. The teeth, with the position of the nose at the end of the snout, but attached to the skull was a set of tiny thickened ear bones. The only animals on Earth, living or extinct, that have ear bones thickened this way are whales. So that is also a fact. Okay, those are the only animals. I'm going to just highlight that whole thing. So these are all facts. So the thickened ear bones is not what you would see in a wolf, it's what you would see in a whale. So that was a clue right there that what they'd found is a whale ancestor based on the ear bones. Now, I'm going to change colors because notice what comes next. It says they named the creature Pakicetus, whale of Pakistan, based on the land mammal-like features of the skull. Gingrich hypothesized. So hypothesize, that's saying it's an inference. It's a conclusion. A hypothesis is a conclusion based on the facts. So hypothesize that this whale probably went to the water to feed, but came on land to rest and give birth. Oh, I don't want to get this. Let's try that. It's not going to like all that, but okay. That's pretty good. All right, so notice, it's pretty easy to highlight. So hopefully pause the video, go back, make sure you're highlighting on yours as well, okay? So this is what we know so far about Pakicetus. All right, paragraph 6. Notice paragraph 6, 7, and 8 is all about, you can see over the right-hand side, Basilosaurus. So in 1989, Gingrich was mapping the spine of a well-preserved 50-foot-long skeleton of Basilosaurus, a fossil whale that lived about 10 million years after Pakicetus. Two-thirds of the way down the spine, he found a small round bone standing vertically. This seemed out of place, and the top was weathered away. When the rest was excavated, the bone proved to be an upper leg bone with the knee joint preserved. No one had ever seen the knee of a whale before. Counting down the spine, so paragraph 7, this bone was near the 48th vertebra. The whole team went to work brushing away the sand away from this part of all the Basilosaurus that had been mapped so far. Soon they found, astonishingly, not only more hips and upper legs, but also lower leg bones, ankles, and finally, one by one, the bones of 3 tiny toes. These were the first hind limbs and feet ever found with a fossil whale skeleton. In paragraph 8, Basilosaurus was a huge ocean-going whale with retracted nostrils forming a blowhole half the way up its 4-foot skull. Its body was equipped with legs, but they were too small to support the weight of the animal on land. All right, so now let's go back to those paragraphs and look for observations or facts about Basilosaurus. So we see a couple of things here. I see measurements now. We didn't see that before with Pakicetus, but that's important. When they were mapping the spine of a well-preserved 50-foot long skeleton. Okay, I'll go ahead and highlight that. A fossil whale that lived about 10 million years after Pakicetus. So that means it's younger. 2/3 of the way down the spine, he found a small round bone standing vertically. When it was excavated, the bone proved to be an upper leg bone with a well-preserved knee joint. So it's upper leg and a knee. Then, if we go to the next paragraph, what did they discover? Let's see. Okay. Soon they found astonishingly not only more hips and upper legs, but also lower legs, ankle bones, and one by one, tiny toes. So in this fossil, they have an upper leg, lower leg, ankle, knee, and toes. Okay. Then it says they were the first hind limbs and feet ever found with a fossil whale skeleton. Now, I would almost say that that's a conclusion. So, based on what they've seen, they're making a conclusion that this is a whale that has limbs. Okay, so that's a conclusion based on the evidence they found. All right, paragraph 8. I did see some facts in paragraph 8 I wanted to highlight. Basilosaurus was a huge ocean-going whale with retracted nostrils forming a blowhole half the way up its 4-foot-long skull. So with Pakicetus, the first one we read about up here, it says the nostrils were set close to the end of the snout. Now with Basilosaurus, it says right here that the nostrils were about halfway up the skull and was forming a blowhole. Okay, so the nostrils in a different position and it's more whale-like for sure. And then it also tells us that the skull is 4 feet long. So we know the whole skeleton is 50 feet long based on the fact right here, and that the skull is 4 feet long. All right. Let's go ahead. I'm going to change. So a conclusion is this is an ocean-going whale. Maybe. Let's try that again. So a conclusion is it's an ocean-going whale. Also, that it was equipped with legs, yes, but it was too small. The legs were too small to support its weight on land. Now, when we read about Pakicetus, it says that the whale probably went to water to feed, but came out to land to rest and give birth. Whereas Basilosaurus, it did have legs, but they were very tiny legs, and it wasn't able to support its weight on land. So it had legs, but they didn't work on land. Okay, the very last section is about two fossils, Ambulocetus and Rhodocetus. So paragraph 9. Gingrich predicted that scientists would unearth many more missing links between land and sea whales. He wasn't disappointed. Some of the most important finds were yet to come. In the 1990s, Thaassen and Gingrich discovered two whales that were almost as old as Pakicetus. Both had legs larger than Basilosaurus, even though the skeletons were only 10 to 12 feet long. One was named Ambulocetus and the other Rhodocetus. Like Pakicetus, both of these whales found their food in the water and were good swimmers, but both still hitched their way ashore to rest and give birth. All right, so these two fossils sounds like they were in between Pakicetus and Basilosaurus. It said they were almost as old as Pakicetus, and in this article, Pakicetus is the oldest fossil we read about. So let's look for the facts. It says the two whales were almost as old as Pakicetus, but let's find a little more details about them. Both had larger legs than Basilosaurus. That's important. So the legs, and we can see this is the picture right here of Rhodocetus, and it had 4 limbs. Definitely those hind limbs are described as being larger than Basilosaurus. And we learned up here Basilosaurus had tiny hind limbs and it wasn't able to support its weight on land. Then it tells us that the skeletons were between 10 and 12 feet long. Now remember, we highlighted for Basilosaurus, it was a 50-foot long skeleton. So Basilosaurus was much longer than the Ambulocetus and the Rhodocetus. The last thing, both of these whales found food in the water and were good swimmers. Well, that's not something they observed happening. That's a conclusion they made based on the evidence, because they couldn't see them do that because they're just fossils. But based on the fossils they found, a conclusion or an inference they made is that both of these whales found food in the water and were good swimmers, but both still hitched just the main, they came on land to rest and give birth. So that sounds a lot like Pakicetus, not Pakicetus, yes, Pakicetus. We learned Pakicetus also went to the water to eat, but came to land to rest and give birth. Okay, so this is what you should have highlighted in your article. If you need to go back through the video and pause it to make sure you get to the same highlights, again, the color I was using, yellow, is what I highlighted the observations or facts about each fossil, and then green is what I highlighted the inferences, okay? So if you have any questions, please send me an email, but this is what I expect you to have done. We're working on this in class Monday and Tuesday, and then you're going to be using your article for assignment number 13. Okay, thanks for watching.